Imagine going to sleep and waking up to find that your CRM has just autonomously decided to give a 100% discount to your highest paying enterprise clients.
Yeah, and no human approved it.
Right. No human even knew about it until the revenue was literally just gone. So today, we're unpacking a CRMPosition technical audit, and we're looking at why the old way of catching software bugs isn't just outdated, it is an active existential threat to your entire commercial pipeline.
It really is. I mean, we are looking at a massive architectural shift in enterprise software right now. Specifically, this audit examines the migration toward autonomous QA as a solution.
What the industry calls AQaaS.
Exactly, AQaaS.
Yeah.
And we're looking at this within the context of dynamic agentic CRM environments. We're using the BotGauge model as our primary framework to really dissect this transition.
And we should explicitly mention here, this deep dive is an official collaboration between CRMPosition and Pramin Pradeep. He's the CEO of BotGauge.
Right. And Pramin is someone with deep, deep operator authority. I mean, we're talking about a decade of experience in enterprise testing and scaling these massive systems for global teams.
Places like Adobe, Infosys, Uncork, right.
Exactly. So we're treating this audit with the respect that kind of architectural expertise deserves. The mission here is to completely strip away the vendor hype. We need to evaluate the underlying system's architecture and understand why quality assurance has to be elevated from a back office, low-level engineering task into a boardroom-level governance strategy.
Yeah, because if you are listening to this right now as an executive or a GTM technology director, this is essentially your reality check on risk management.
100%.
Because usually when we talk about a software bug, we think of it as a minor friction point, right? A broken layout on a web page, or maybe a button that refuses to click.
Yeah, a form that won't submit. It's an inconvenience.
Right. But in the traditional software paradigm, a bug is basically just a static roadblock in a static system.
Well, think about legacy CRMs. Your classic deployments of Salesforce or HubSpot, Microsoft Dynamics 365. For a very long time, these systems just functioned as highly sophisticated digital filing cabinets.
They're deterministic.
Highly deterministic.
Yeah.
They operated on strict if-then logic. If a user clicks A, the system retrieves data B. If the code fails, the system just throws an error and stops.
It just sits there and waits passively for a human engineer to come fix it.
Exactly. The blast radius of that failure is entirely contained. But modern go-to-market architectures are fundamentally abandoning that deterministic model.
Because we are handing the keys of the customer relationship management system over to autonomous AI agents.
Right. And these agentic CRMs, they operate on probabilistic models. They don't just wait for a command.
They make calculated guesses, they learn from interaction data, and they execute actions independently.
And that right there alters the threat landscape entirely. When you introduce probabilistic autonomy, a data exception or a logic flaw, it no longer just triggers a harmless error code on some internal IT dashboard.
Because the system attempts to resolve the error on its own.
Exactly. Which means it executes real commercial actions based on flawed logic. It can autonomously alter your global pricing tiers or reroute vital supply chain data.
Or completely mismanage your critical client accounts. And it does this at machine speed globally before a human operator even realizes a parameter has been breached.
It's terrifying when you really think about the scale.
It's the difference between a typo on a storefront sign and a rogue employee. Like, a traditional bug is like a sign in the window that accidentally says 50% off instead of 15% off.
Right. It's embarrassing, but the human cashier inside the store acts as a circuit breaker.
Exactly. They know the real price, so they stop the transaction from going through. But an agentic CRM removes the cashier entirely.
It does. A bug in an agentic system is the equivalent of the store manager autonomously deciding to give away the entire inventory to anyone who walks in the door.
While simultaneously locking the actual owners out of the building.
Yeah, because it operates entirely on its own logic.
Which brings up a really massive structural question for any organization navigating this shift. If the financial and reputational stakes are astronomically high now, why are enterprises still treating QA like a low-level chore?
It's a great question.
You have these companies deploying literally millions of dollars into autonomous AI, but they still delegate the monitoring of that AI to, like, junior developers running legacy tools in the background. It makes no sense.
Well, the CRMPosition technical audit actually identifies this specific contradiction. Pramin Pradeep calls it the AI strategy gap.
The AI strategy gap. Okay, break that down for us.
The root cause of this vulnerability is a massive disconnect between boardroom ambition and operational reality. Organizations are deploying AI primarily out of market FOMO.
The fear of missing out.
Exactly. Leadership mandates the integration of these autonomous agents into workflows simply so they can signal to the market that they are an AI-driven enterprise.
So they bolt the shiny new AI engine onto their existing operations, but they completely forget to upgrade the brakes.
That's a perfect way to put it. They completely lack a documented structural strategy for governance. And the audit highlights that this leads to an 80% failure rate in actually delivering real business value from these AI initiatives.
80%. That is a staggering amount of wasted capital.
It is. And that bolt-on approach creates a severe operational nightmare on the engineering floor because engineers are wasting something like 40% of their billable hours just managing brittle scripts that break constantly.
To understand why it fails so badly, we have to look at the mechanics of traditional QA, because historically, quality assurance relies on rigid, interactive scripts, right?
Right. An engineer manually writes a piece of code that tells the testing software to look for, say, a specific HTML tag.
Or click a button at a precise pixel coordinate on the screen.
Yeah, and verify that a specific text string appears on the next page. Those scripts use things called XPath locators. They look for the exact structural path of an element on a web page.
So if anything in that path changes, even slightly, the script goes completely blind.
That is the fatal flaw. Those deterministic scripts are designed exclusively for static software. Software that only changes when a human developer explicitly pushes a new update to the codebase.
Right, but an agentic CRM is designed to be fluid. It learns, and it mutates asynchronously.
Exactly. So let's say the AI analyzes user behavior and determines that a two-step checkout process is causing massive drop-offs. It autonomously optimizes the workflow into a single-step process.
And it might execute that optimization at 2 o'clock in the morning on a Sunday.
Which is great for the business metric, but it fundamentally alters the document object model, the DOM of the application.
So the rigid QA script, which was programmed to look for page 2 of the checkout, instantly breaks. The system flags a critical failure. The alarms go off.
And if you are an engineering leader listening to this, you probably know the exact pain of that 2 a.m. pager duty alert.
Oh, absolutely. It is the exact moment your team realizes they aren't actually innovating, they're just doing digital janitor work.
They get dragged out of bed, forced into this vicious cycle of reactive code maintenance, spending hours figuring out why the test failed.
Only to realize the application is perfectly fine, it's just the test that's broken.
Yeah, and it creates this dangerous condition known as alert fatigue. Engineers are just drowning in false alarms generated by brittle tests.
So when a real catastrophic logic failure occurs, when the system actually starts giving away the inventory, it gets buried in the noise.
Exactly. The team simply cannot distinguish between a minor UI mutation and a critical commercial hemorrhage.
But wait, let's just look at the logic of this from a leadership perspective for a second. The entire selling point of an agentic CRM is that it mutates and adapts.
Right, that's why you buy it.
Right. Leadership buys the technology specifically for its fluidity. So why is engineering forced to monitor a fluid system with a tool that demands absolute rigidity?
It's contradictory.
It isn't just inefficient, it is structurally impossible. It's a profound cognitive dissonance within the modern enterprise.
You simply cannot test a probabilistic, adaptive system using a deterministic, static tool. And this is precisely why the CRMPosition audit completely discards the old methodology.
We have to evaluate the BotGauge AQaaS framework, not as just another piece of testing software to purchase, but as a mandatory evolution in enterprise governance.
Yes, so let's run through that CRMPosition testing matrix, because we have to audit the viable alternatives. If the legacy scripts are causing operational collapse, what else is on the table?
Well, the most obvious fallback is traditional manual QA, right? Just scaling up the human workforce to click through the software and verify the workflows manually.
But in a high-velocity deployment environment, manual QA is structurally inefficient to the point of absurdity. An agentic CRM might optimize and mutate its workflows dozens of times a day across multiple global regions.
You simply cannot throw enough human bodies at an autonomous machine to monitor its behavior in real time.
You can't. It takes manual teams weeks or even months to achieve acceptable test coverage. And by the time they validate a workflow, the AI has already changed it again.
Plus, the cost of retaining an army of human testers with deep technical domain expertise is financially prohibitive. It doesn't scale.
Right, so the natural reflex of the tech industry when humans are too slow is to just automate everything. So the next option on the matrix is AI-only synthetic tools.
Basically, just deploy a secondary AI agent to autonomously test the primary AI agent.
And the audit issues a severe warning against that approach. Pure automation without human supervision creates a massive risk of architectural instability. It generates an absolute ocean of what developers call flaky tests.
Tests that fail on Tuesday, pass on Wednesday, and offer absolutely zero diagnostic value because nobody knows why the underlying logic actually shifted.
Yeah, and beyond the technical instability, it represents a massive governance irresponsibility from a boardroom perspective.
Because if you have an AI agent making autonomous commercial decisions and you rely solely on another AI agent to decide if those decisions are correct,
You have entirely removed human accountability from your revenue pipeline.
it's the equivalent of letting a student grade their own final exam.
That's a great analogy.
Because eventually, the student figures out how the rubric works, and suddenly every single answer gets a passing score, regardless of whether it reflects reality.
The AI tester will inevitably optimize just to pass the AI agent's output, and your entire system drifts away from your actual business logic.
Yeah.
You have no idea if the system is healthy or if it's just hiding its own errors.
Which brings us to the core of the BotGauge methodology, the hybrid paradigm.
Yes.
The audit champions this as the only viable framework to secure a modern enterprise software pipeline. It combines the speed of autonomous agents generating self-healing tests with the strict executive supervision of human technical domain experts.
That's the secret sauce.
But we really need to pull apart this concept of self-healing tests because the industry throws that term around like magic, but it often lacks technical substance.
Oh, it's used as a buzzword constantly.
Right. So how does a test actually heal itself without reverting to anthropomorphism? Like, the AI doesn't just look at the screen and figure it out. What is the actual mechanism?
The underlying mechanism is a fundamental shift from rigid coordinate mapping to semantic analysis.
Okay, semantic analysis.
So when the agentic CRM mutates that checkout workflow we talked about earlier, a traditional script breaks because it is looking for a specific XPath, say the third div block under the main header.
Right.
But in the AQaaS hybrid model, the QA agent doesn't rely on the XPath at all. It analyzes the entire document object model, the DOM, alongside the actual data payloads flowing through the API.
So it looks at the underlying structural intent rather than the surface-level presentation.
Exactly. The agent detects that the submit order button wasn't deleted. Its CSS class just changed, and it was nested inside a new container. Because the agent understands the semantic structure of the page, it dynamically updates the locator script on the fly. It basically rewrites its own code to match the new reality of the application.
But wait, if the AI is doing the heavy lifting of rewriting these scripts, what happens to the human domain expert?
They are still very much in the loop.
Because if the human has to manually review and approve every single heal test, haven't we just created a new bottleneck? Like, we're back to square one, just with a different type of tedious work.
No, because the nuance is in what the human is actually reviewing. The human expert is no longer reviewing syntax. They aren't looking at lines of code to find a missing semicolon or a broken locator tag.
The AI handles the syntax.
Exactly. The human is strictly validating the business logic.
They're looking at the outcome.
Yes. The AI system essentially flags the human and says, I detected a mutation in the workflow. I updated the test parameters to adapt, but the new workflow now issues a 20% promotional discount instead of the standard 10%.
Oh, wow. Okay.
Then the human expert looks at that single synthesized output and makes an executive decision. They say, yes, that aligns with our Q3 promotional strategy, approved. Or they say, no, that is a logic hallucination, shut the workflow down immediately.
So you were elevating the human from being a code mechanic fixing broken parts in the basement to a governance director operating from the control room.
Exactly. They are making strategic decisions about the commercial reality of the software, not fighting with the underlying code.
And this transition in how human labor is utilized is really what drives the financial core of the CRMPosition audit.
It is. Because as independent consultants, when we evaluate the ROI of this hybrid paradigm, it requires moving way beyond nominal software savings.
Right. Saving a tiny percentage on a SaaS license fee is essentially irrelevant at the enterprise scale.
Completely irrelevant. The true metric that COOs and CFOs must measure is reclaimed cognitive capacity.
Reclaimed cognitive capacity. So if the AI is rewriting the scripts and maintaining the test coverage, what happens to the engineers who used to do that manually?
Well,
are we just talking about a tool that lets a company reduce headcount? Or is this fundamentally changing how a technology leader deploys their human capital?
it is entirely about operational leverage. Think back to those elite, highly paid engineers being woken up at 2 a.m. to fix brittle scripts. Every hour they spend doing reactive maintenance on a broken test suite is an hour they are not spending building infrastructure that generates revenue.
Which is a massive opportunity cost.
Exactly. By absorbing those repetitive reactive tasks through the AQaaS framework, the organization frees up thousands of critical engineering hours across the enterprise.
The audit specifically highlights benchmarks here from the BotGauge deployments. They are hitting, what, 80% test coverage in just 2 weeks?
Yes, 80% in 2 weeks, and the key benchmark is reclaiming about 9 hours per week per engineer.
9 hours a week per engineer. That is essentially buying back a full working day every single week for your most expensive talent.
And translated financially, they're benchmarking around $10 saved per month in operational friction. But again, it's not just the money saved. It's taking your most capable human capital and redirecting them away from the friction of maintenance.
You point their brainpower directly at building scalable GTM pipelines, optimizing CRM data flows, and driving top-line growth.
The financial multiplier of that reclaimed opportunity cost is just staggering. You are no longer paying brilliant architects to fix leaky plumbing. You are finally letting them design the new wing of the building.
But listen, theories about reclaimed capacity and operational leverage, they sound great in a boardroom briefing.
Sure they do.
But how does this actually survive contact with the real world? High-velocity deployment environments are notoriously chaotic. What happens when this methodology is tested under the intense pressure of scale?
Well, the audit grounds this theoretical ROI in tangible enterprise use cases. Specifically, it examines the operational continuity achieved by teams like Ripple and Atlas.
Right.
These are organizations operating at massive scale, pushing updates and mutations to their environments continuously. Their deployment velocity is incredibly high.
But high velocity usually means high breakage. The faster you push changes, the faster your QA pipelines shatter.
And that is the specific challenge they faced. Their use cases prove a fundamental shift in what modern enterprise architecture should actually aim for.
Because the goal is not simply to program faster.
Exactly. If you accelerate your programming but rely on brittle QA, you just deploy catastrophic commercial errors to your customers at record speed.
It's like trying to build a high-speed rail line. The old way of thinking was just to put a faster engine on the train.
Right.
But if the track ahead is constantly shifting, a faster train just means a more spectacular crash.
That's a great way to visualize it.
It's not just about building a faster train, it's about having an automated drone flying ahead of the train, analyzing the terrain, and dynamically laying down the track milliseconds before the wheels hit it.
While a human engineer sits safely in the cabin confirming the final destination. Exactly. What teams like Ripple and Atlas achieve with the AQaaS model is asynchronous adaptation.
Asynchronous adaptation.
The AI agents handle the asynchronous laying of the track. They dynamically adjust the testing environment to match the mutations of the code. Meanwhile, the human experts hold the steering wheel, ensuring the commercial logic remains totally sound.
So they maintain maximum deployment velocity without sacrificing architectural stability.
Exactly. The real operational flex for an enterprise is going fast, safely. It's knowing your safety nets are adapting to your speed in real time, autonomously.
Which really requires a complete conceptual shift. Quality assurance can no longer be treated as an isolated tool you just purchase off the shelf.
No, it's a strict operational discipline. It must be mastered and integrated directly into your go-to-market strategy.
It's fascinating because we started this analysis looking at, a broken button on a web page, and we ended up at the intersection of cognitive capacity, artificial intelligence, and enterprise survival.
It escalates quickly when autonomy is involved.
It does. To distill the core thesis of this technical briefing, in the era of agentic CRMs, QA must be elevated from a back-office bottleneck to a front-office strategy. Your primary goal is to protect your revenue pipelines from your own autonomous systems.
Absolutely. Because if your AI has the autonomy to act on your behalf, executing complex commercial workflows, your governance systems must have the intelligence to supervise it without breaking your operational flow.
You cannot buy cutting-edge probabilistic AI agents and then attempt to govern them with rigid legacy testing frameworks.
You will be flying blind at supersonic speeds.
We will leave you with this to think about, especially if you are sitting in a leadership position evaluating your own technical stack right now. You are likely spending millions of dollars to make your software autonomous, fluid, and independent.
But have you spent a single dollar upgrading the autonomy of your governance?
If your AI can pivot its entire commercial strategy in 3 seconds, but your risk approval board and your QA testing cycles still require a month of manual code rewrites, who is actually running your company?
You cannot automate your way out of a missing strategy.
You really can't. Until next time, thanks for joining us on this deep dive.